All right, guys. Hello. Welcome back to our next video on experimentation. In previous videos, all about research methods, we talked a lot about the descriptive studies, case studies, naturalistic observation, and surveys. We also spent some time talking about the correlational studies and what correlations mean. And remember, correlation does not equal causation. So that leads us to here. After looking at scatter plots and survey data and sampling and wording effects, we are finally at psychological experiments. So let's talk about the purpose of an experiment, okay? A lot of times we like to think that experiments are better than the other types of research strategies, and that's not entirely correct to say. There is definitely a difference. There's a reason why we focus a lot more on experimentation than, say, survey results in this class. But I wouldn't say that any are necessarily better or worse than the other. The purpose of an experiment is to establish cause and effect. That is the number one purpose of why we do experiments. And if they are done correctly, they will show that. We talked in the previous video about correlations, right? Correlations showing how two traits or behaviors tend to react either in similar or in opposite ways. But we said that we could never draw that causal link, right? That link that shows that one of these things causes the other. But for experiments, we can. Again, assuming that we do them the right way, we can make a claim that one thing causes another. And the way that we're going to kind of walk through this and learn about experimentation is by looking at each of the specific components. I'll be talking about how they work, and then we'll be getting into some of the vocab along the way. Okay, so let's start with a general hypothesis. Okay, a general hypothesis is just something that it can be very simple in terms of what are we going to be studying, right? I think we know hypotheses from other science classes, and it's the same thing here. It is a guess that you're framing your research around. So in this case, a general hypothesis could be that food affects learning. Now, that is very vague, right? What do we mean by learning? What do we mean by food? So in psychology, it's important, in most sciences, it's important that we have a more specific hypothesis, or to use a psych term, an operationalized hypothesis. We'll talk about this later, and you'll be doing some work with some practice on some worksheets on operational definitions, as they're called. But basically, what you can see from this example is I've defined what food means, which is an oatmeal raisin cookie. And I've defined what learning means, which is higher average scores on the semester final. Okay. Notice that it is a lot more specific, right? The specific part of this is important, which we'll get to later. But in this case, I've operationalized food to mean oatmeal raisin cookie before class each day, and learning as higher average scores on the semester final. And notice here we have students who get the cookie and students who don't get the cookie, right? There's that breakdown as well. So let's kind of move forward here and start talking about some of our experimental variables. Okay, so if eating cookies before each class will lead to a higher average score, that is kind of a more simplified version of our more specific hypothesis. Then we have to think about variables. And when you think about variables in science, you should always be thinking about independent and dependent variables. And we have them here in psych too. So the independent variable is the variable that's controlled by the experimenter. It is the variable that is the cause variable, right? It's the thing that shows the cause. So in our example, what is causing the change that we want to study? Eating cookies, right? Eating cookies is the independent variable in this case. It is because the independent variable, in this case the cookies, causes a change that we're trying to measure. The dependent variable is the one that is predicted by the experimenter. So instead of the one that is controlled, right? In control, I mean, the experimenter determines who gets a cookie and who doesn't. which then either causes a change or it doesn't. The dependent variable is the one that is affected by the independent variable. Right? The independent variable changes the dependent variable. So it's the thing that is predicted. It's kind of the what the experimenter thinks might happen. And that is usually also called the effect variable, right? So if we're talking about cause and effect, what causes what effect? So, I'll pause again. And in this case, the dependent variable is scores, right? It's the higher average scores. So these are our two variables. And in every psych experiment, just like in every chemistry experiment, you're going to have an independent and a dependent variable. The difference here is with psych, it gets a little bit murkier, and we need to make sure that we are explicitly clear with our language about what we're studying. Okay, so we've got our hypothesis again. What if kids get cookies and get A's? Okay, that's what we're hoping for, right? That is the hypothesis. So in order to make sure that we do this in some sort of standardized way, we need to put people in groups, right? We can't just give everybody cookies because that's not going to help learn or teach us anything. So we establish groups. Those groups are then exposed to two different levels of the independent variable. We'll talk more about levels of the variables in a little bit. But basically, we're just starting with the groups here. So one group, the experimental group, is the one who is exposed to the independent variable. In other words, the experimental group is the one who gets the cookie. Okay, they're the ones who are receiving the cookie. Now, there are other students, if we're doing this well, which we should be, right? Because we're trying to understand and make sure that we have data here. There is a control group. The control group is not exposed to the independent variable, right? They are not exposed to the independent variable, which means they don't get any oatmeal raisin cookie before every class. This way, we can accurately measure if there's a difference between those students who received a cookie and got an A and those students who didn't receive a cookie and didn't get an A, right? If the thing that is different between the two groups is whether or not they got the cookie, then we can reasonably say that that the cookie is what caused the change, right? The oatmeal raisin cookie caused the change in the scores. Now, let's kind of recap. So the independent variable leads to the dependent variable. The experimental group is the group that receives the cookie, and let's say that in this case that their average score was a 95% on the final, right? That's pretty good. That's very good. But it also doesn't tell us anything because we don't know what the control looks like. So let's say that we have the control group, and the control group, as we know, doesn't get the cookie, and they have an average of an 82%. Now, let's take a look at these two numbers here. Those are pretty different, right? I think if I asked you guys what you'd rather have, an 82% or 95%, you would all say 95%. There's not many people that would rather have the C plus than the A, especially here at Holy Ghost. So just from what we've learned so far, are we sure that it is the cookie that is causing the change in scores? And we can't say that just yet. Couldn't there be another type of thing that influences the scores and the whether or not they got a cookie? And I'm going to pause and let you think about what they could be. Maybe even write it down in your notes. What do you think is another explanation for why the experimental group got 95% and the control group got 82%? Whatever you guys came up with, we have a name for it. And those are called confounding variables, right? I mentioned these in I think the correlation video. Confounding variables are a third variable that can influence the results of our study. That happens in correlation studies. I said why we can't use correlation to mean cause and effect. It's because there could have been a third variable there. Here we have the same thing, right? We have potentially other variables that get in the way. So let's say that the experimental group right, you guys know that we have, actually, this is perfect. We have a red and a blue, right, breakdown during Ghost. Or let's say that I have two sections of our psych class, which I also do. But I have two sections. One section, let's say, meets in my classroom, Founders 201. And the other class meets in the tent, the way where we were supposed to be. Um, And let's say that in order to keep things easy for me and make sure that I know how many cookies to get or whatever, I just make sure that all of the people who get the cookie are the ones in the Founders 201 class, and all the guys that don't get the cookie are in the tent. In fact, the two sections of psych that I have are evenly split, so this is a nice way for me to divide it. But couldn't the fact that some students are learning in the classroom that I normally teach the material in, with all of my wonderful decor that helps stimulate the mind and make you ask questions about psychology, couldn't that have an effect on maybe why some people are getting higher scores? Maybe it could be that the tent is pretty warm and muggy and full of bugs, and that there's other things that are going on that are affecting learning. So we would call those a environmental confounding variable, right? So in order to try to correct for those, we want to make sure that both conditions, both groups are in similar environmental conditions. If one group meets in the classroom, the other should meet in the classroom. If one group meets, in the morning, then the other group should meet in the morning. There shouldn't be long distances or differences or time changes or anything like that. Between the two groups. We want to make the conditions as similar as possible because, remember, in order to show causation, we need to make sure that the independent variable is the only explanation that we could have for the change in the dependent variable. So if we get everything else similar, then we can accurately say that the IV changed the DV. Now let's say that we got every class in Founders 201, so we don't have the environmental concern, but I'm still going to give one section the cookies and one section not the cookies. Couldn't it be that the class that gets the cookies, um, maybe they know the experiment that I'm running? Maybe I tell them, hey guys, as part of the class this year, we're going to run an experiment. You guys are going to be receiving cookies before class every day, because I'm working on a theory that eating before class will help with your scores. You guys are going to get the cookies, but the other class isn't. Couldn't there be some kind of trickery going on here, right? Couldn't I, as the teacher, maybe teach better to those kids who are receiving the cookies, whether intentionally or unintentionally, right? Maybe to the best that I can, I'm going to keep things the same, but who knows? Maybe my expectations are a little bit different. What about the student expectations, right? What if you're in the class that doesn't get the cookies? Does that mean that you're just destined to be dumb, that no matter what you do, you'll never be as good as your friends in the other section, right? How does that knowledge impact your behavior in class? And couldn't that create a difference in the change of your scores? So we have another confounding variable, an expectation confounding variable, right? This is a confounding variable where my expectations, as say the experimenter, or your expectations as the subject of the experiment, can kind of color the way that the experiment comes out. Intentionally or unintentionally, right? There's bias in things that we do. So in order to eliminate bias and expectations, psychology and psychological experiments frequently go through what's called a double blind process. That is where neither the experimenter nor the subject knows what group they're in. So think about it as there's, like let's say a drug trial, right? Or a vaccine trial. Half of the people in that trial are receiving a vaccine to test out to see its effectiveness. The other half are getting nothing. They're getting an injection of saline solution, or a sugar pill, something that has no medicine in it at all, right? The purpose of that is to compare the expectations so that the person who's doing the study doesn't know who received which, doesn't know who received the independent variable or doesn't know who received a placebo. Plus, the subject of the experiment doesn't know either. All they know is they got a shot. They have no idea if it was the actual, thing, that the medicine that they're testing, or if it was just, some sugar pill or some saline solution. And that is a way to help limit the confounding variable that surround expectations. Let's say that it just so happens that all of the guys in the one section are the top of the top students. Let's say that for whatever reason, the way that the schedule was broken down, that one of the sections is just full with valedictorian contenders and just guys who are at the top of the class, and the other section isn't. They just don't have as smart as students. Couldn't that cause a difference in the scores? And it's true, it's a confounding variable related to individual differences. So there's a lot of ways in which we can make sure to limit individual differences. And one of the ways we do that, and actually can help eliminate all confounding variables, is through a process called random assignment. Random assignment is one of the most important terms that you're going to hear. So I'm going to kind of spend some time in this and basically walk slowly so that we all understand it. Random assignment is the process by which participants are selected for either the experimental group or the control group. Random assignment means that you are equally likely to be either placed in the experimental group or the control group. That there is usually something that is done by chance to help determine which group you go into. There should be no prior knowledge into making sure, oh, well, he's pretty good, so let's put him in this group, or he's pretty bad, let's put him in this group. Those things aren't going to work because then it's not random. Now, you might be getting a little confused here. It sounds a lot like I'm talking about random sampling. But let's keep in mind a couple of things here. Random sampling, in terms of surveys, random sampling is used to select participants from a larger population. Right? Think back to the image with all the beads in the jar, right? We can either count all of the beads in the big jar, or we can take a sample and count all of those. If it's a random sample, then you don't need to count every member of the population. You can just count your sample. What does that do? That allows you to generalize your results, right? It allows you to take the information that you got from your sample and apply it to the population at large. Right? The whole group that you're trying to study. That's random sampling. Random assignment, on the other hand, is used to divide the participants into the different groups, experimental and control group. And what this does is it controls for confounding variables. By not knowing which group someone goes into which group, by that person not knowing what group they are in, all they know is that they are, either going 1 or 2, or A or B, or left or right, or whatever it is, that there is some sort of way to control for confounding variables. And that's through random assignment. And we'll do something in class to kind of highlight just how that works. Okay, so again, random assignment means that the participants who may have been selected by random sampling, like let's remember that, the participants in the study that you have, that you're going to do the experiment on, say there's 40 of them, you need to put 20 in one group and 20 in the other. That's random assignment. How did you get those 40 participants? Maybe that's random sampling, right? Maybe it's not. Maybe it's just whoever signed up to be part of the study. But it could be random sampling. So random sampling gives you your pool of participants, and then that, if it's done well, allows you to generalize your results to the larger population. Random assignment is how you determine who's going to be in what group. And if you do it well, then that's going to control for all of those other variables that could help explain a certain behavior. Okay, I'm going to stop here because it's hitting about 20 minutes, and it's important for to keep those videos short. So we'll pick back up at the next video talking more about experimental design.